Good afternoon, dear students.
Good afternoon.
Yes, so we have discussed, okay, so we are discussing the chapter solutions, okay. So we have seen the type of solutions, then we have, okay, then we have seen the concentration terms, okay, expressing how we express the different methods, okay. So we have seen the different methods for expressing the concentration of solutions, right? So these were the expressions which we have seen. Then we had started with solubility, right? Solubility, then the factors affecting the solubility, right? Then the solubility of first we have seen solubility of solid in liquid, then we had seen solubility of uh, gas in liquid, okay. So based on the solubility of solid in liquid, okay, then we had seen the effects, so like effect of temperature, effect of pressure, how it affects your solubility, right? So these things we have discussed. And then we had started with something called as Henry's law, right? In the previous session, I have just told you the law. So as I have already told you, Henry's law is very important. Okay, asked for 2 marks. So they'll ask you define Henry's law with its mathematical expression. Okay, so that time you have to write the law and you have to explain the mathematical term. So what is Henry's law? So once again, I'll just tell the definition of what is Henry's law. So Henry's law, it is applicable for what? It is applicable for the solubility of gas in a liquid. Okay. So here, when you keep the temperature constant, okay, when the temperature is constant, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas, okay, which is present above the surface of the liquid or solution. So this is what? This is Henry's law. So Henry's law, we can consider in terms of mole fraction. Solubility is nothing but mole fraction. Okay. Solubility is nothing but concentration. Solubility is nothing but concentration. And we have seen what are the different concentration terms which we can use. So which are the different concentration terms we have seen? Molarity, mass percentage, volume percentage, mass by volume percentage, mole fraction. So these are the different ways of expressing the concentration. So as you know, solubility is nothing but concentration, and concentration can be expressed in different ways. Okay. So mole fraction. So we are taking which concentration term? We are taking mole fraction. Why? Because in mole fraction, we can easily calculate what? We can easily calculate the number of moles. What can be calculated? Number of moles can be calculated. So we are relating the partial pressure, okay. So partial pressure of a gas, it is directly proportional to the solubility. So solubility is nothing but concentration, and concentration we are expressing in terms of mole fraction. Okay, so mole fraction, so it can also be measured as mole fraction of a gas in a liquid is proportional to the partial pressure of the gas above the liquid or solution. So the Henry's law, it can be stated as the partial pressure, because we are expressing the solubility in terms of what? We are expressing the solubility in terms of your concentration. So concentration is nothing but we are taking here what? We are taking mole fraction. So we are defining it in terms of mole fraction. Now, the partial pressure of a gas in a vapor phase is proportional to the mole fraction of the gas. So it is represented, mole fraction is represented by chi. Okay, it is like X in the solution. So, so what happens? So here Henry's law, it depends on what? It depends upon, or it tells you about the effect of pressure. Okay, it tells you about the effect of pressure on solubility, of gas in a liquid. Okay, in a gas in a liquid. So this is the effect. So your Henry's law, it depends on what? It depends on the effect of pressure on solubility of a gas in a liquid. Suppose if I take a container, okay, I take a container and I take liquid in this. I take liquid in this, and the gas molecules are, okay, gas is nothing but your solute. I have added the gas, the solute also, okay, to the your solvent, which is a liquid. Now what I'll do, I'll compress it. Compress means I'm putting pressure from above. Okay, I'm putting pressure from above. Okay, I'm putting the pressure from above on this. So what will happen to the solubility? So solubility will increase. So as you are increasing the pressure on this okay, beaker containing the liquid and the gas, okay, what is happening? The solubility also increases. So as we know that partial pressure is directly proportional to what? It is directly proportional to solubility of gas. Okay, it is directly proportional to solubility of gas. So here solubility is nothing but what? I have told you, solubility is nothing but your concentration. Solubility is nothing but concentration. Okay. Now solubility is what? What do you mean by solubility? As we have already discussed, solubility is nothing but it is the amount of solute which is dissolved in a given liquid, right? We know now what is solubility. Solubility is what? It is the amount of substance, okay, amount of solute which is dissolved in the given liquid. Now, what is our solute? Our solute is the gas. So, how much gas is dissolved in the liquid? So, solubility tells you how much amount of solute is dissolved in the given liquid. So, as we know, solubility is nothing but concentration. So, partial pressure can also be related to concentration. Okay. Now, we know different methods of expressing the concentration, but the best way to express the concentration is mole fraction. Okay, it is expressed by mole fraction because we can calculate the number of moles. Okay, we can calculate the number of moles, and if it is expressed as chi, it is expressed as what? It is expressed as chi. Okay, so partial pressure, if I remove this proportionality sign, then I have to introduce the proportionality constant. What I have to introduce? I have to introduce a proportionality constant. So which is the proportionality constant? So I am introducing KH. So KH into chi. Okay, so this is the mathematical expression. So what is KH? KH is the Henry's law constant. KH is what? Henry's law constant. Okay, so this is the, and you know what is chi? Chi is your mole fraction. Okay, so this is the Henry's law and its mathematical expression. Is it clear? Yes, is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. So Henry's law, one more time, I'll state the Henry's law. So Henry's law states that the amount of gas that is dissolved in liquid is directly proportional to what? It is directly proportional to the partial pressure of the gas. And what is the important? That temperature should be kept constant. Okay. So your partial pressure, that is the solubility of a gas in the liquid, is directly proportional to the partial pressure. Okay, the condition is that the temperature should be constant. So P will be equal to KH into chi. Okay, where KH is your Henry's law constant and chi is your mole fraction. Okay, so as you know, okay, if there is a liquid and your gas solute particles, so and if I put the pressure from above, as the solubility increases, as the pressure increases, solubility also increases. Okay, so this is the about the Henry's law. Okay, now we'll see what are the factors. What are the factors which are affecting the Henry's law? Okay, so Henry's law, what are the factors which are affecting? So what are the factors affecting Henry's law constant? Okay, that is Henry's law constant is KH. So KH, so this way value of KH, it depends on nature of gas. It depends on what? It depends on nature of gas. It depends on what? Nature of gas. Okay, it depends on what? Nature of gas. So this is the first one. So it depends on nature of gas. So you know that the condition is at constant temperature. Okay, at constant temperature. So the KH values, KH has different values. The KH will have different values for different gases. So the KH values are different for different gases. So I'll give you some values. So this is gas, different gas, and they are KH values. So gases like H2, helium, N2, and O2. H2, the KH value is 69.16, He is 144.97, N2 is 76.48, and O2 is 34.80. So these are the different values. So KH value, it depends on what? It depends upon the nature of the gas. So it depends on nature of the gas. So whenever the temperature is constant, okay, so these are the different values. You can see for H2, the KH value is different. For He, the KH value is different. So it depends on the nature of the gas. Then second condition is that the KH, okay, it depends on temperature. It depends on temperature. Okay. Now gas. If I have a gas, temperature, and the KH value, okay. So gas, like I have taken oxygen, okay, and there are two temperatures. So if I take 293 and one more as 303, okay. So KH value, you can see here 34.86 and here it is 46.82. So also it depends on the KH value, it depends on temperature. So you can see for this temperature, the KH value is different, and for this temperature, the KH value is different. Okay. Now, as you know, what is the mathematical expression for Henry's law? P is equals to KH into chi. Okay. Now, you know that if we keep your now pressure constant, if we keep pressure constant, okay, pressure constant, then how will be the equation? KH will be inversely proportional to chi. Is it? KH will be inversely proportional to chi. If I keep this pressure constant, then KH will be inversely proportional to chi. Okay. So if I increase the value of KH, what will happen to the mole fraction? The mole fraction will go on decreasing, right? If I increase the value of KH, what will happen to the mole fraction? The value of mole fraction will go on decrease. The solubility go on decreasing, right? Now here, if I increase the temperature, suppose if now here, if I increase the temperature, so I'll take again a beaker. In that, what is there? Liquid is there, and your solute molecules are there. I am increasing the temperature. What will happen to the solubility? What will happen to the solubility? Solubility will decrease. Okay, solubility will decrease. So solubility decreases. What will happen to the mole fraction? Mole fraction also decreases. So this is the okay. So KH. So KH value, it depends on what? It depends on both the nature of the gas as well as it depends on the temperature. Okay. So remember this thing. So when you are talking about temperature, so KH value is directly proportional to temperature. Okay. Please make it a note. KH is directly proportional to temperature. Okay. Is it clear, these two factors? So first is at so KH value, it depends on nature of gas. Second, it depends on temperature. Okay. So you can see here, first point, different gases have different KH values at the same temperature. Okay. That is at a constant temperature. That is KH depends on nature of gas. Then second one, higher the value of KH, now we are okay, this we are going to see solubility. Now this we have seen KH value of a particular gas. What will happen to the KH value of a particular gas? So as we increase the temperature, okay, as we increase the temperature, the KH value also increases. Okay, it indicates that solubility of the gas decreases with increase in temperature. So these 2 points we have seen, first and the second one. Is it clear, these 2 points? Okay, fine. So we'll see the third point. This one. Okay. So that is, it depends on the factors which are affecting Henry's law is also solubility of gas. Okay. Solubility of gas. Now solubility of gas. So as you know, KH value is inversely proportional to solubility of gas. Okay, solubility of gas. So it is inversely proportional. So make this also a point. So KH value is directly proportional to temperature. This was the second fact we have seen. And okay, and the third one is what? Solubility of a gas is direct inversely proportional to the KH value. Okay, so as the KH value increases, what will happen to solubility? The solubility will decreases. Okay, the solubility will decreases. So these are the factors which are affecting the Henry's law. Is it clear? Okay. So we'll move forward. Next is, okay, next are the application of Henry's law. Now where we are using this application of Henry's law. So this Henry's law, okay, how it came into picture? Henry's law came into picture depending upon the solubility of a gas in a liquid. Okay, that what happens when at constant temperature, okay, the solubility of a gas in a liquid, okay, what will happen is directly proportional to its partial pressure. So as pressure increases, solubility of a gas in a liquid also increases at a constant pressure. So this was, so based on that, Henry's law was given. Now how this Henry's law is applicable and where it is applicable? Okay, so Henry's law, as we know, Henry's law, it is due to the effect of pressure on the solubility of a gas in a liquid. So the first which we are going to see is in soda bottles. Okay, in soda bottles. Okay, here you can see first one. So first is in the soda bottle. So the application is used in the soda bottles. You know, soda bottle, okay, or the carbonated soft drinks. Okay, when you open the cap of the soda bottle or the any soft drinks, carbonated soft drink, what you can observe? What do you observe? Yes, what do you observe? Yes, there will be release of some gas, right? There will be, yes, yes, there will be release of some gas. So what is happening in there? Yes, so soda and carbonated drinks. So the soda and carbonated drinks, what they are done? So they are packed. Suppose I take a can. Okay, visualize this is a Coke can. Okay, you have seen Coke can. Yes, so this is a Coke can. So this is the tin of that Coke can. Okay, now here what we have done. Okay, so this is a Coke. Okay, a tin of the Coke. So what is done? Soda and this carbonated drinks. Okay, soda and the carbonated drinks, they are packed. How they are packed? They are packed under high pressure. So high pressure is put. Okay, high pressure is put, and what is done? The soda bottles are packed. Okay, with a high pressure. So what happens? So that there will be increase in the solubility of a gas. You know, as pressure increases, solubility of a gas also increases. Right. So what is done? What is there in this can? Yes, it is nothing but gas. Okay. A gas is what gas is pumped. Okay, with a high pressure, and what you have, you have a, that is which gas it is? It is a carbon dioxide gas. Okay, so carbon dioxide gas with high pressure and some sugary liquid, right? The and some sugary liquid is present in this can. So what is done? So soda bottles and these carbonated, any carbonated drinks, what is done is they are packed under very high pressure so that there will be increase in the solubility. There will be increase in the solubility of carbon dioxide gas in the liquid. As you know, that pressure is directly proportional to what? Pressure is directly proportional to solubility, right? So this is the way. So what is happening here inside the bottle? Inside the bottle, what will be the pressure? Pressure will be high or low? Yes, inside the bottle, what will happen? Now the tin is closed. Okay, the tin is closed. Now imagine inside the tin. Okay, what is how will be the pressure? Yes, Sri Varuni has answered it as high pressure. Yes, good. Yes, Yamuna, Ramya, yes, it is correct. So pressure will be more. Okay, inside the tin, yes. So the pressure will be more. Then what will happen to solubility? Solubility will be also more. Yes, solubility also will be more. Now what you have done? Now you have opened the tin. Now I have opened this. I have opened the lid of the Coke. Now what will happen to the pressure and solubility? Now what will happen to the pressure and solubility? Yes, now I have opened the tin. Once you open the tin, okay, what will happen? Once you open the tin, gas will come out, right? Gas will come out. And when you open this, gas comes out, right? Gas comes out. Now, which is this gas? Carbon dioxide gas. Okay, carbon dioxide gas comes out. This comes in contact with the, what you say, uh, it comes in contact with the air. Okay, it comes in contact with the air. What will happen to the pressure? The pressure will decrease. Okay, the pressure will decrease. And what will happen to the solubility? Solubility also decreases. Yes, there will be decrease in the solubility. Yes, good. Yamuna, Suraya, Ramya, Srivaruni. Yes, the answer is correct. Misbah, yes. Good. Okay. So you have understood. So how it is applied, right? So like this, the laws are applied in our day-to-day life. Okay. Simply the laws are not given. So we are using them in our, so there are some application of these laws. So like this. Okay. So under high pressure, the gas is compressed with a sugary liquid. Okay, and what is happening? So as the pressure increases, the solubility also increases. Once the lid is open, okay, what will happen? The gas will expel out. The gas will expel out. And what will happen? The pressure will decrease and the solubility also decreases. So this is the, what is that? Uh, the application of your soda bottle, okay, in your carbonated drink. So what happens when the bottles are opened? Some of the gas will come out, right? Some of the gas will expel out. You have seen. So when you open the soda bottle, the gas comes out, right? And it gives you a pop sound. Did you hear some pop sound? Pop sound will come out in from the soda bottles, right? Some pop sounds will come. So there will be some pop sound. Okay, there will be some pop sound which will come out when you open the soda bottle. Why? This shows that there is a lower pressure. That is, the pressure is lower. So how the pop sound comes? This shows that the pressure has been lowered. Okay, above the liquid, and carbon dioxide gas will be easily escape. And how it escapes out? It escapes out in the form of bubbles, right? It escapes out in the forms of bubbles, right? You have seen this. You can imagine these, right? You might have drank a lot many time. Okay, the carbonated drinks, Coke, Pepsi, or any drink. So any carbonated drink. So you might have noticed this thing. So next time you can experience it one more time. Okay, so how this Henry's law is applied, okay, in this carbonated drink. Is it clear? This first application is clear?
Yes, ma'am.
Okay, fine. So we'll go for the second application. So the second application is in deep sea diving. Okay, scuba divers. Yes, scuba divers. Okay, so this is applied in diving. Okay, the person who goes deep inside the sea. Okay, they are called as diving. They are called. It is called as scuba diving. Okay, uh, so for the marine life and all. Okay, some people now do scuba diving, right? You dive into the sea, deep sea, so that you can see some aquatic life. So usually the scuba divers do this. Okay, how do they carry? They have their how the aeronauts have their what do you say? Mm, the clothes. Okay, this like silver color aeronauts how they use. So scuba divers also they have their costume. Yes, the word is costume. So how the astronauts have their costume. So like this, some special costume is made for scuba diving also. So they have a cylinder in behind them. Okay, so that as you know, as you go below depth of the sea, the oxygen level goes on decreasing, right? So that it is provided by the external source with those cylinders. The person who is going deep inside the sea, okay, he can breathe through that cylinder. So this is scuba diving. Now imagine, okay, I have a, so this is the, okay, so this is the surface. Okay, this is the surface. This is the surface of the sea. Okay, surface where you people might have, okay, you go and what you go up to here, okay, by walk or something. So this is the surface of the sea. And remember, and this what I have drawn. This is a bottom deep inside the sea. So this is a bottom of sea. So this is bottom of sea. It is very deep. Okay, it is very deep, and this is very closer. So surface of the sea, it is very closer, and the bottom, it is very deep. Now, what is happening here? Suppose a person is there. Okay, now a person is there. This person goes inside here. Okay, here. What will happen to the pressure here? What will be the pressure experienced by the person here? Will it be high or it will high? Will it be low at the surface? The pressure will be a person is there. Okay, he is near the surface of the imagine yourself. Okay, imagine yourself, you are there near the surface of the sea. What will happen to your pressure? The pressure will be high or it will be low? It will be lower. Yes, Yamuna has answered it right. So the pressure will be, or pressure will be, I'll use another color. Okay, so pressure will be low. Okay, pressure will be low. Now, what will happen to solubility? Solubility also will be low, right? Solubility also will be low. Now, this person has dived inside. Dived means he is uh, diving inside. He is going deep inside the sea. Okay, and he has reached now here. The person has reached in the deep sea. Okay, now what will happen to the pressure? Now, what will happen to the pressure of this person? The pressure will be high. Yes, good. So pressure will be high. Okay, I'll explain you. Just tell me the terms, then we will explain. Yes, so Bhagya, Ramya, yes, Yamuna have answered it right. Okay, good. Shri Varuni, yes. So it is pressure will be high. Now what will happen to the solubility? Solubility also will be high, right? Now at this point, okay. Now what will happen? So pressure will be high, solubility also will be high. Now what divers do? They dive, okay, from the surface. So from the surface, they go inside the deep sea. Now what will happen? Now what will happen? Okay, here the pressure will be low. Means what? The solubility of the air in the bloodstream, okay, of the diver will be normal here. So, what is that? In the blood, okay, the oxygen which you take, it gets dissolved, right? Now here it will be normal, it will be low. But as you go deep inside the sea, what will happen to the solubility of air? The solubility of the air in the bloodstream, okay, of the diver will be high. Okay, it increases. Okay, now here what will happen? along with oxygen, you will inhale some of the nitrogen also. Okay, along with oxygen, you will inhale some of the nitrogen also. Now, what will happen after when you go deep inside, you have inhaled some of the oxygen and nitrogen into the bloodstream. Okay, the because the air because you have inhaled the that is your the solubility of the air in your bloodstream, okay, will be high. Now what is happening now? Again this person, okay, he has dived, his work is over here. Now again he is going back to the surface. Again he is going back to the surface. Now what will happen to the solubility? Again when he reaches the surface, the solubility will be, pressure will be low, and the solubility also will be low. Okay, but what is happening here? When the diver, okay, when the diver, he moves back to the surface. When the diver, yes, when the diver, he moves back to the surface, what will happen? Due to the low pressure, okay, due to its low pressure and low solubility, whatever the nitrogen gas, okay, whatever the nitrogen gas he has been taken, okay, it will start moving out of the body. Okay, it will start moving out of the body, because here when he had went inside deep into the sea, he had inhaled some of the nitrogen gas. Okay, now when he goes deep inside again, when he goes back to the surface, what will happen? Whatever the oxygen nitrogen gas which he had inhaled, it will come out of the body. How it will come out of the body? Through respiration. Okay, through respiration. Respiration means taking in of uh, this, okay, oxygen and giving out of carbon dioxide. So like that, the whatever the nitrogen gas which he had taken, which has been absorbed by his body, soluble in his bloodstream, so that is given out through the respiration. It is given out by the body. Now what will happen? How he is giving out the nitrogen? Okay, how the nitrogen is leaving? So like that, in the body, the blood clot starts. What will happen? Blood clot. Okay, blood clot, it will form. So why the blood clots are forming? The blood clots are forming due to nitrogen bubbles. Whatever the nitrogen he has taken, okay, so because of that nitrogen, the blood clot starts forming in his body, and due to this blood clots, there can be nerve breakdown can be possible. Okay, nerve breakdown is possible. Breakdown is possible. So this is what is taken place, what factors are taking place inside a person who is doing a scuba diving. Is it okay? So how to prevent this? Okay, is it clear till here? The air which is used for scuba diving is diluted to HU. Okay, this is the what you say. Precaution. Okay, so understood how the pressure is high at this low at the surface, and how it becomes these things are clear, whatever has been told till here. Yes, so one more time I'll explain. So at the surface, what will happen to the pressure? The pressure will be low. Okay, of the scuba diver, whoever is the person is there, his pressure will be low. As the pressure is low, solubility also will be low. Now this person who is at the surface, he went deep inside the sea. Now what will happen to the pressure? Pressure will be high, solubility also will be high. As you know, pressure is directly proportional to solubility. Now when he goes deep inside the sea, what he has done, the solubility of the air in the bloodstream of the diver will be high. Okay, it goes on high, and he will he has respired some of the oxygen along with nitrogen. Okay, now when he comes back again to the surface of the sea, what is happening here? Here again the pressure will be low and the solubility will be low. Okay, so what will happen due to low solubility? Whatever the nitrogen he has been taken, okay, it will be it starts to move out of the body. How? Through respiration. Okay, and what will happen to the body? In the body, blood clots will start to form. Okay, due to nitrogen bubbles. Now the because of this, there can be nerve breakdown. Okay, nerve breakdown will be possible. Now, how to prevent this? How to prevent this? Okay, now how we can prevent? So whatever the cylinder, so previously the cylinders which the divers were carrying, it had some oxygen along with nitrogen. Okay, previously in the cylinders, there was a combination of oxygen and nitrogen. Now it is banned. Okay, now it is banned. So because the scuba divers are uh, they're facing so big issue. Okay, health hazard. It is a health hazard. So what is done? So oxygen along with helium, so the cylinder containing oxygen along with helium, so that is used nowadays by the scuba divers because helium is less soluble as compared to nitrogen. So helium in the bloodstream, it is less soluble as compared to nitrogen. So we are making use of oxygen plus helium. Okay. So as you know, in deep sea, the pressure will be high. What will happen? Then the pressure of the gas at the surface of the water. So as you know, when the person he is present deep inside the sea, the pressure will be high as compared to that at the surface of the sea. Okay, so as the divers go inside, as they go inside and inside, what will happen? They inhale highly pressurized gas. Okay, so in this highly pressurized gas, what is present? Nitrogen is present, right? So because of that, uh, what is that? We are making use of the this cylinder, that is O2 plus H. Is it clear? So how it can be prevented? So it is a question is asked. Okay, how the scuba divers? Uh, there is one question based on this. Just a second. So applications are very important. Okay. Applications are very important. So they will ask you the question. So how it can be prevented? How the scuba divers can prevent themselves from this nerve breakdown? Okay. So what you have to use? You have to use the oxygen plus helium cylinder because helium is less soluble as compared to nitrogen. Okay, so the deep sea divers breathe under high pressure underwater. At high pressure, the solubility of the gas in the blood increases, but when they come towards the surface, the pressure will decrease. Okay, so and the dissolved gases, whatever the dissolved gases are there, they will come out in the form of bubbles. Okay, and this will block the capillaries. So this medication condition is known as bends, and this is very painful and dangerous. So this nerve breakdown, whatever the nerve breakdown takes place, it is called as bends. Okay, and this how it can be, how the bends can be prevented? It can be prevented by diluting it with He. Okay, so this is the prevention. Is it clear? Is this application clear? Second application of diving.
Yes, ma'am.
Okay. Fine. So okay, there are two more applications. I'll write it here. Now, the third is at high altitudes. Okay, when you go at high altitude means when the person, okay, when they travel, when they do mountaineering and they reach at the high altitude. So that time also what will happen? As you go above, okay, as you go move to the higher altitude, what will happen to the pressure? Pressure will decrease. So there will be less oxygen because of less oxygen dissolved in the bloodstream. Okay, so here the pressure will be high. Okay, here the pressure will be high, surface will okay, and as you go down above, what will happen? The pressure will decrease and your solubility of the oxygen in the air bloodstream also decreases, right? So what the mountain climbers do, as they have to travel at the height, they will carry oxygen cylinders with them. Okay, they carry oxygen cylinders because lower oxygen levels in blood may okay, when you travel at a higher heights, so there will be lower oxygen level. So as lower oxygen level means as the oxygen level decreases, what will happen? The person can suffocate. Okay, he can feel restless. Okay, he can feel restless because if you just hold your nose for 5 minutes, okay, how you will be restless? So same way, when the person is traveling at a higher altitude, okay, what will happen? He will feel restless. Okay, and so he needs to carry a oxygen cylinder. So he may suffer suffocation, or there can be death also. Sometimes death also is possible. Okay, so because of that, the person who are moving at a higher altitude should carry a oxygen cylinder, because as you go high at higher level, the oxygen, the solubility of oxygen in the bloodstream goes on decreasing. Okay, so this was the third application of Henry's law. Then the fourth is Henry's law in respiration. Okay, in respiration also Henry's law is applicable. How we respire, how we take in oxygen and give out carbon dioxide. So as you know, pressure is directly proportional to solubility of gas. Okay, it is directly proportional to solubility of gas. So what will happen? The amount of gas which is dissolved in the bloodstream is directly proportional to the partial pressure of the gas. So as you know that, so as you are taking in the oxygen, so this is directly getting dissolved in the bloodstream. So this is directly proportional. So the amount of gas which is dissolved in the bloodstream is directly proportional to the partial pressure of the gas in the air. Okay, so this is the application of Henry's law. So these are the four. So a person, okay, if he is taking oxygen, okay, when he is taking oxygen, what will happen? The pressure will be more. Okay, as the pressure increases, solubility of oxygen in the air also will be more. Okay, so these are the application. Is it clear?
Yes, ma'am.
Okay, just a second. Next is next we are going to discuss about vapor pressure. Okay, next is vapor pressure. Next is vapor pressure. Okay, so what is vapor pressure? What is vapor pressure? So vapor pressure. So consider you take a beaker, okay, and you take a liquid. There is a liquid. You take a volatile liquid. What do you mean by volatile liquid now? What do you mean by volatile liquid? So volatile liquid are those which changes into vapors. They easily change into vapors. So they are called as volatile liquid. Okay. Now in this volatile liquid, so whatever the molecules are present in the volatile liquid, they are present at the surface, right? They are present at the surface of the this. Okay. So this is the liquid level. So whatever the liquid that is volatile liquid is there, its what is that? Its molecules are present at the surface. Okay. Now, what is vapor pressure? Okay, whatever the pressure which is exerted by the vapor of the liquid. Okay. Now, what will happen? whatever the beaker you have taken. Okay, now I'll heat it. Okay, what I'll do, I'll apply a external temperature. Apply the external temperature. Now what will happen? Whatever the molecules are there, okay, at the surface, they will start to evaporate, right? They will undergo a process called as evaporation, right? So if I take a liquid in the beaker, okay, volatile liquid in a beaker, whatever the molecules, okay, they are at the surface of the liquid. Now, when I apply a external temperature, now what is happening? As the temperature is okay, so the whatever the molecules are there, they'll start evaporating, right? You know, if you take water, imagine water, you have taken water in the vessel. Okay, what will happen? After some time, the water bubbles will start, and the some of the water, okay, it will start to change into vapors, right? So same way, it will start getting evaporated. Okay, now at the same time, and this is a closed, okay, and this is a closed vessel. This is a closed vessel. Now it will start to evaporate. Okay, it will start to evaporate. Now at the same time, as it is a closed vessel, so what will happen? So the vapors, so vapors will start. Okay, it will start to form vapors. Okay. Now at the same time, what will happen? These vapors will condense, right? They will condense back. Okay, so they will condense back. So in this process, what is happening? In a closed container, what we have done, I'll repeat it again. So in a closed container, I have taken liquid, a volatile liquid. I have applied a external temperature. Okay. Now at the surface of the liquid, there are molecules present. Now these gas molecules, as the temperature increases, they will be undergoing evaporation. So they will evaporate, they will form vapors. Okay, they'll form vapors, or you can call them as gas. Okay, so they form the vapors, or they are forming the gas molecules, right? Now this gas molecules, so as it is a close, so simultaneously there will be condensation also. So there will be condensation of this drop, so some of the droplets can come back. Now you know, whenever you close a lid on the surface of the any vessel, okay, a hot vessel, you have seen some of the droplets, they form droplets and they come back again into that vessel, right? So this is called as condensation. Okay, now so at the same time there is evaporation and condensation. Now whatever the pressure which is exerted by the vapor of the liquid on this surface, on the surface of solution or liquid, okay, when a equilibrium is established. Now what is this equilibrium? Equilibrium is nothing but, as the molecules are turning, okay, the rate of evaporation, as the molecules are converting or into vapors, at the same time they are coming back, or they are forming, they are taking place condensation. So at the same time condensation is also possible. So this is a equilibrium state. So the vapors, so that time, so when this state is reached, when this state, that is the rate of evaporation is equilibrium, okay, with a rate of condensation. So at this, whatever the vapor, okay, whatever the pressure which is exerted by the vapor is called as what? Vapor pressure. So this vapor pressure, it is established between the liquid and its vapor, and your liquid will be a volatile in nature. So how many number of vapors are formed, they will not what play any role. So what is that? It is when this equilibrium is reached, okay, when this equilibrium is reached, that is the rate of evaporation is in equilibrium with rate of condensation. So that time whatever the pressure is exerted by the vapors on the liquid is called as the vapor pressure. Is it clear what is vapor pressure? Yes, vapor pressure. Okay, fine. So this is the vapor pressure. So, so we are going to see what are the factors which are affecting the vapor pressure. Okay, what all are the factors which are affecting the vapor pressure? So this is the vapor pressure. So remember, the equilibrium is very important. So I'll repeat one more. Vapor pressure is the pressure which is exerted by the vapor of liquid on the surface of solution or liquid when equilibrium is established between liquid and its vapor, when where liquid is volatile in nature. Okay, so this is the vapor pressure. Okay, now what are the factors? So I'll clear this. Now what are the factors which are affecting the vapor pressure? So the first one is temperature. First one is what? Temperature. 2 minutes, students. I'll continue. Okay, so what are the factors? Okay, so what are the factors which are affecting the vapor pressure? So first one is temperature. So again, so consider I have a beaker, okay, and I have what? A liquid into that, and there are what is that? It is a liquid, okay. So this is a liquid. So molecules, so it is a volatile liquid. So as a volatile liquid, at the surface, what is present? At the surface, your uh, the gas molecules, the molecules of the liquid is present. So when you apply the temperature externally, okay, as the temperature will increase, what will form? The vapors will form. Okay, the vapors will start to form at the top, okay, at the surface. Now what will happen as the temperature increases? Okay, as the temperature increases, what will happen? More vapor will be formed. Okay, more vapors will be formed. So what will happen? As a result, there will be rise in vapor pressure. So as you know, so as the temperature is increasing, what will happen to the what will happen as the temperature increases? There will be result in the more vapor pressure because more vapors are forming. As more number of vapors are forming, they will give rise to what? They'll give rise to more vapor pressure. So this is the first. So remember that temperature is directly proportional to vapor pressure. So as you are increasing the temperature, what is happening to the temperature? As you are increasing the temperature, more number of vapor are forming. Okay, more numbers of vapors are forming, and in turn there will be rise in vapor pressure. Okay, now as the temperature increases, as you know, as the temperature increases inside this uh, inside the container, what will happen? These vapors, okay, these vapors will gain some kinetic energy. What they'll gain? They'll gain some kinetic energy. And what will happen to this? Just a second. Okay, so what will happen as the molecules are forming. So as the temperature is increasing, so more vapors will form, and these vapors, they will gain some kinetic energy. Okay, and they will move faster as they are getting some kinetic energy. Okay, and what will happen as they move faster, they will hit the walls of the container or they will collide with each other. So as a result, the vapor pressure also increases. So this is about temperature. Then second is nature of liquid. Second is what? Nature of liquid. Now what is nature of liquid? So when you suppose again I take the liquid. So whether the molecules are weak or the molecules are strong. So depending upon the liquid, if they are weak, if the intermolecular forces between the molecules are weak, then these molecules can be easily broken, right? If the bonds are stronger, if the bond present between the molecules is stronger, then it is very difficult to break, right? So weaker the intermolecular forces. If the intermolecular forces are weaker, then vapor pressure will be more or less. Yes, can you tell me? See here, the how is the nature of liquid? So nature of liquid depends upon the intermolecular forces. What are intermolecular forces? The force which holds the two atoms. Okay. Now, if the intermolecular forces are weak, it can be easily broken. If the intermolecular forces are strong, okay, it is very hard to break. Now, if the intermolecular forces are weaker, what will happen to vapor pressure? Will it be more or less? What will happen to the vapor pressure if the intermolecular forces are weaker? The vapor pressure will be more. Yes, good. Yamuna has answered it. It is more. So vapor pressure will be more. Okay. Then as the force between the molecules are weak, okay, what will happen? It can be easily broken. So the atoms can be easily broken and the vapors are formed easily. So what will happen? The vapor pressure will be more. Yes. So as the vapors, yes, Suraya, Yamuna have answered. Good. Okay. So as what will happen as the forces are weak between the atoms, it can be easily converted into vapors, and in turn the vapor pressure will be more. Okay. So the example of this we will discuss it in the next class. Okay. So there are two more factors. So again I'll repeat the factors in the next class. Okay. So there are four factors: temperature, nature of liquid, then boiling point and purity of liquid. So this we will take in the next class. Okay, is it clear? Whatever the things are told up to vapor pressure, what is pressure? Yes. Yes. Okay, fine. So no doubts, or you have doubts? So if you have doubts, you can ask me. Okay. So I shall end the session here. Okay. We will meet in the next class. Okay. And we'll see the factors and remaining things. Thank you, dear students.